Ever wondered what it takes to create those tiny, paper-thin discs that help millions see the world clearly? You might think contact lenses are simple, but their creation is a fascinating journey involving high-tech chemistry, precision robotics, and medical-grade manufacturing that will blow your mind. Stick around as we pull back the curtain on the hidden world of contact lens production. It all starts with a design. Long before a lens ever touches an eye, engineers and optical scientists map out its every detail. They design the exact curvature, the precise thickness, and the optical strength needed to correct vision, whether it's for nearsightedness, farsightedness, or astigmatism. Each design is a digital blueprint for perfection. This initial stage is the foundation for the millions upon millions of lenses produced every single day around the globe. Once the design is locked in, the real magic begins with the raw materials. The process starts with a special liquid polymer. Think of it as a kind of high-tech goo that has the incredible ability to become soft, flexible, and perfectly transparent once it's cured. This liquid is measured with microscopic precision and then injected into a series of tiny, custom-made molds. Factories typically use one of two main methods to shape the lenses. The first is called spin casting. In this method, the liquid polymer is dropped into a spinning mold. Centrifugal force pushes the liquid outward, spreading it into a thin, perfectly curved lens shape. The speed of the spin determines the lens's power and curvature. It's a bit like a tiny, high-speed potter's wheel for your eyes. The second, and more common method, is cast molding. Here, the liquid polymer is sandwiched between two mold halves. The bottom half shapes the front of the lens, and the top half shapes the back. When the two halves are pressed together, the liquid fills the cavity, taking on the exact shape of the final lens. This technique is known for producing incredibly consistent and smooth lenses with flawless optical clarity. It's the go-to method for most disposable lenses used by today. Now that the liquid polymer is in the mold, it's time to solidify it. This is the curing stage. Depending on the specific polymer, this is done using intense UV light, heat, or a carefully controlled chemical reaction. Timing here is absolutely critical. If the curing process is too short, the lens will be unstable and flimsy. If it's too long, it becomes brittle and uncomfortable. It has to be just right. This entire process, from injection to curing, is fully automated. Robotic arms and conveyor systems move with incredible speed and precision, ensuring every single lens is made to the exact same standard. After curing, the molds automatically open, and delicate robotic arms gently lift out the newly formed lenses. At this point, they're still in a hard, rigid state. Each lens is immediately inspected for any initial defects. We're talking about tiny imperfections like air bubbles, uneven edges, or slight variations in thickness that would be invisible to the naked eye. Automated cameras and scanners check every single one. The next stage is one of the most transformative: hydration. The rigid, freshly made lenses are submerged in a sterile saline solution. This is where they absorb water and transform into the soft, pliable hydrogel material we're all familiar with. This step is designed to make the lens mimic the natural moisture level of the human eye, ensuring it feels comfortable and natural from the moment you put it in. The amount of water a lens can hold is a key factor in its comfort and breathability. Once hydrated, the soft lenses are carefully placed into individual blister packs, still filled with a sterile saline solution. But they aren't ready for your eyes just yet. Now comes the most important phase of all: quality control. Because contact lenses are medical devices that sit directly on the cornea, the standards for safety and quality are unbelievably strict. There's absolutely no room for error. Factories use a battery of high-tech inspection tools. High-resolution microscopes and laser scanners check each lens for surface smoothness, edge precision, and optical clarity. Automated cameras verify that the shape and curvature match the original design specifications. down to the micron. Machines also test the lens's water content, its oxygen permeability, which is crucial for eye health, and its flexibility. Any lens that fails even one of these dozens of tests is immediately discarded. It's a ruthless process, but it's what guarantees your safety. With quality checks complete, the lenses move on to sterilization. This is a non-negotiable step for any medical device. The sealed blister packs are typically loaded into a massive machine called an autoclave, which uses high-pressure steam to sterilize them. This process kills any and all microorganisms, ensuring the lens is completely sterile when you open the package. Every single sterilization cycle is carefully documented to comply with global health regulations, like those from the FDA in the United States or ACE mark in Europe. After sterilization, the blister packs are ready for final packaging. Labeling is just as regulated as the manufacturing itself. Each pack is printed with the lens's prescription power, its base curve, diameter, an expiration date, and a lot number. This lot number is crucial for traceability. If a defect is ever discovered, the manufacturer can instantly track down the entire batch, no matter where it is in the world, and issue a recall. This is a critical safety net. The blister packs are then automatically sorted and boxed up, ready for distribution. From the factory, these boxes are shipped to warehouses and then on to optometrists' offices, pharmacies, and online retailers worldwide. The logistics are complex, as the lenses must be transported in temperature-controlled environments to maintain their sterility and hydration. The sheer scale of this operation is staggering. Some of the world's largest factories ship out millions of individual contact lenses every single week. So, who are the major players in this industry? You've probably heard of them. Brands like AccuView, made by Johnson & Johnson, are famous for their focus on comfort and UV protection. Then there's Air Optics and Dailies from Alcon, which are known for their high oxygen permeability. Cooper Vision's Biofinity lenses are popular for their long-wear comfort, and Bausch Plus Lomb offers its own advanced materials with its Ultra line. And we can't forget cosmetic lenses like the Fresh Look brand, which add another layer of complexity with color printing. These companies are constantly competing and innovating, pushing the boundaries of material science to make lenses more comfortable, safer, and healthier for our eyes. So, from a puddle of liquid polymer to a sterile, precisely engineered medical device, the journey of a contact lens is a masterpiece of modern manufacturing. It's a perfect blend of chemistry, robotics, and incredibly strict safety protocols. The next time you pop in a fresh pair of contacts, take a moment to appreciate the amazing science and technology that went into making that tiny, vision-correcting wonder. It's so much more than just a piece of plastic. Thanks for watching. If you found this look behind the scenes interesting, don't forget to hit that like button and subscribe for more videos. See you in the next one.